The sun, our life-giving star. But the sun has a hidden fury. It can unleash bursts of energy called solar flares, and sometimes it throws a tantrum of epic proportions, flinging out vast clouds of plasma. We call these coronal mass ejections, or CMEs. Imagine 1 billion tons of superheated matter hurtling through space at millions of miles per hour. That's a CME. And if Earth happens to be in its path, well, let's just say it's not good news. And when they do, they can wreak havoc on our technologically dependent world. The Earth has a protective magnetic field, a shield against the sun's wrath. But a powerful CME can punch through this defense, disrupting our way of life in ways we can barely imagine. The good news is that we're not sitting ducks. Scientists are constantly monitoring the sun, looking for signs of trouble. And we're developing technologies to protect ourselves from the worst of a solar storm. But the first step is understanding the threat. What happens when a CME hits Earth? How bad could it be? And what can we do about it? Let's find out. Imagine a CME, a silent, invisible storm slamming into Earth's magnetic field. The sky erupts in an ethereal dance of light auroras far brighter and more widespread than ever witnessed. But this beauty masks a hidden danger. The impact sends a jolt of energy through our planet, a surge of electricity that races across continents. This is the first punch of a CME, a blow to our electrical infrastructure. Power grids designed to handle the ebb and flow of normal electricity use become overloaded. Transformers, the workhorses of our power system, overheat and fail. The lights begin to flicker, then die, plunging cities into darkness. But the chaos doesn't stop there. The CME's energy disrupts radio waves, scrambling communications, air traffic control systems go haywire, grounding planes, GPS satellites, our guides in a digital world, start sending inaccurate signals, throwing navigation systems into disarray. In an instant, our interconnected world begins to unravel. With the power grids down, our technological dependence becomes our Achilles heel. Hospitals, reliant on backup generators, face dwindling fuel supplies. Water treatment plants grind to a halt, jeopardizing clean water access. Communication networks, the backbone of modern society, fall silent, isolating communities and hampering emergency response. The financial sector, heavily reliant on constant data flow, freezes. ATMs become useless, electronic transactions impossible. Global markets thrown into chaos by the lack of communication and data face potential collapse. The digital world, once a seamless extension of our lives, becomes a stark reminder of our vulnerability. But the impact extends beyond our immediate needs. Satellites, orbiting high above the Earth, are particularly susceptible to CME damage. Their sensitive electronics, bombarded by the sun's radiation, malfunction or fail entirely. Weather forecasting reliant on satellite data becomes unreliable. Global communication networks already strained face further disruption. Our window into space and our connection to each other is severely compromised. The impact of a major CME goes beyond flickering lights and spotty internet. It disrupts the very fabric of our daily lives. Transportation systems reliant on electricity and communication grind to a halt. Trains stall mid-journey. Traffic lights go dark, and gas stations unable to pump fuel become useless monuments to our dependence on fossil fuels. Supermarkets, stripped bare by panic buying, struggle to replenish their stock. Supply chains already strained break down completely. Food and medicine shortages become a grim reality. The conveniences we take for granted, clean water, refrigeration, readily available fuel, disappear, forcing us to confront the fragility of our modern existence. In the absence of communication, information becomes scarce and unreliable. Rumors spread like wildfire, fueling fear and uncertainty. Communities once connected by technology become isolated, forced to rely on their own resources and resilience to weather the storm. The long shadow of the sun. Long-term consequences. The immediate aftermath of a CME is only the beginning. The long-term consequences are potentially even more severe. The widespread damage to power grids could take months, even years, to repair. The economic impact from lost productivity to the cost of rebuilding infrastructure would be staggering. But the damage goes beyond the material. The loss of critical satellites could cripple scientific research, weather forecasting, and global communication for years to come. The disruption to our technological progress could set us back decades, forcing us to rethink our reliance on vulnerable systems. Moreover, the psychological impact of such a catastrophic event cannot be underestimated. The fear, uncertainty, and potential for social unrest could have long-lasting effects on our collective psyche. The experience could force us to confront our vulnerability, prompting a fundamental shift in our relationship with technology and our place in the cosmos. Can we weather the storm? Strategies for mitigation. The prospect of a major CME might seem like a doomsday scenario, but it doesn't have to be. While we can't prevent solar storms, we can prepare for them. By understanding the risks and taking proactive steps, we can mitigate the impact and build a more resilient future. One crucial step is strengthening our power grids. By upgrading transformers, incorporating redundancy, and developing new technologies to manage power surges, we can make our electrical infrastructure more resistant to solar storms. Investing in microgrids, localized power systems that can operate independently, can provide essential services even during widespread outages. Early warning systems are critical. By improving space weather forecasting, we can get a heads up when a CME is headed our way. This gives us time to take protective measures, such as strategically powering down critical infrastructure, orienting satellites to minimize damage, and alerting the public to prepare for potential disruptions. Shielding our grid, protecting our power infrastructure. Our power grids, the arteries of our modern world, are particularly vulnerable to CME-induced geomagnetic storms. The good news is that we can make them more resilient. One approach is to harden transformers, the critical components that regulate voltage and prevent overloads. This can involve adding shielding to protect them from the surge of energy caused by geomagnetic disturbances. Another strategy is to incorporate redundancy into the grid. This means having backup systems in place to take over if primary systems fail. By diversifying power sources, utilizing microgrids, and creating multiple pathways for electricity to flow, we can prevent cascading failures and ensure a more robust power supply. Furthermore, developing smart grid technologies can enhance our ability to manage and respond to solar storms. These intelligent systems can detect anomalies, isolate affected areas, and reroute power to minimize disruptions. By integrating real-time data and automated controls, we can create a more adaptable and resilient power infrastructure. Space-age solutions. Safeguarding satellites and communications. While we can't physically shield satellites from a CME, we can make them more resilient. This involves hardening their electronics against radiation, developing backup systems, and designing them to be more easily repaired or replaced in orbit. Improving space weather forecasting is crucial for protecting our space-based assets. By developing more accurate models and improving our ability to predict the trajectory and intensity of CMEs, we can give satellite operators more time to take protective measures. This might involve temporarily powering down sensitive instruments, adjusting their orientation to minimize exposure, or moving them to a more shielded orbit. Furthermore, we can explore alternative communication technologies that are less susceptible to solar storms. This could involve utilizing fiber optic cables for ground-based communication, developing more robust radio frequencies, and exploring alternative communication methods like quantum communication, which are less affected by electromagnetic interference. Preparing for the inevitable. Building a resilient future. Preparing for a major CME is not just about hardening infrastructure and developing new technologies. It's also about building a more resilient society, one that can adapt and bounce back from such a catastrophic event. This involves educating the public about the risks of solar storms and providing guidance on how to prepare for potential disruptions. This could include having emergency kits ready, knowing how to operate essential appliances without power, and understanding how to access information and communicate during a communication outage. Furthermore, we need to foster a spirit of community resilience. This means encouraging neighbors to look out for one another, supporting local initiatives that promote self-sufficiency, and strengthening community bonds to ensure that we can come together and support one another in times of need. Preparing for a CME is not about succumbing to fear, but about embracing a proactive and solutions-oriented approach. By anticipating challenges, investing in resilience, and fostering a spirit of community, we can weather the storm and emerge stronger on the other side. The human spirit endures. Adapting to a new reality. The prospect of a major CME may seem daunting, but it also presents an opportunity for growth and adaptation. Past challenges have spurred innovation and ingenuity. A CME-induced blackout could inspire a renewed appreciation for the natural world. It could foster a greater understanding of our interconnectedness. It could also lead to innovations in sustainable living. The shared experience of facing a global challenge could foster a sense of global unity. It could inspire us to work together to rebuild and create a more resilient future. Our place in the cosmos, a final word. The threat of CMEs reminds us that we live in a dynamic and sometimes unpredictable cosmos. It underscores our dependence on the sun, not just for light and warmth, but for the very functioning of our technological civilization. But it also highlights our ingenuity, our resilience, and our capacity for adaptation. The challenges we face from space weather are not insurmountable. By understanding the risks, investing in mitigation strategies, and fostering a spirit of preparedness, we can protect our planet and ensure a brighter future for humanity. The cosmos is full of wonders and challenges. As we continue to explore the universe and push the boundaries of human ingenuity, we must do so with a deep respect for the forces of nature and a commitment to safeguarding our planet. The future is ours to shape, and by working together, we can create a world that is both technologically advanced and resilient to the challenges of the cosmos.